Hey everyone, in this video we're going to take a look at two different AWS services. We're going to take a look at AWS's Elastic Container Service, or ECS for short, and then we're going to take a look at AWS's Elastic Kubernetes Service. So what we're going to do is focus on what are the differences between these two services, when would we want to use one over the other, and we're going to highlight what are some of the benefits and the pros and cons of each one of them. So let's go ahead and take a look at everything we're going to cover in this video. So we're going to first start off by going over container orchestrators. We're going to talk about what problems do they solve, why do we need them, and what are the common features and functionalities of a traditional container orchestrator. We're then going to move on to AWS's Elastic Container Service. So we're going to talk about what are the different components that make up ECS. We're going to go over the different terminologies, the functionalities, and the features of it. We'll then move on to Elastic Kubernetes Service, which is AWS's managed Kubernetes service. And we're going to talk about, once again, the building blocks of this service and how it ultimately works. And then finally, once we have a good understanding of the two different services, we're then going to compare and contrast the two. So we're going to take a look at, when would we want to use one over the other? What are the pros and cons of one? And what is the best solution for you and your organization? Now, let's say that we're deploying an application, and this is a microservices-based application, which means we're going to have separate services for each of the different functionalities of our application. We want to ultimately break out our microservices into separate containers. So each service is going to get its own container. And once we've got our containers, we want to then deploy it someplace. So where do we deploy it? It's up to you. We can deploy it on a physical infrastructure. We can deploy it in a virtualized environment. We can deploy it in the cloud. Since we're focused on AWS and specifically AWS services, we're going to deploy it on AWS. And more specifically, we're going to deploy it on AWS virtual machines using the EC2 service. So we're going to create our virtual machines, or our EC2 instances. And since we want to deploy containers, we're going to have to install either Docker or some sort of container runtime so we can physically run containers on our servers. And then once we've got that, we can now finally deploy our application. So we can deploy all of the different containers across all of our servers. Now, the problem occurs is that, what happens when we want to deploy another container? Where does the next container go? How do we figure out what is the best server to deploy our container to? How do we figure out if a server has already reached maximum capacity and maybe we're not able to deploy another container to it? So who's responsible for monitoring the server's available resources so that we could find a server that has more space or more resources available for the next container? And in addition, what happens if a container crashes? Who's responsible for restarting it? Are you going to be manually watching all of your containers and waiting for one of them to crash so that you can restart it yourself? And, during peak traffic hours, how do you scale up your application? How do you deploy more instances of your containers? And how do you scale back down once the load drops below a certain threshold? Well, ultimately, we want to automate all of these different tasks, and all of these responsibilities are associated with container orchestrator. So a container orchestrator is really going to handle a lot of these tasks and do it in a more automated fashion for us. So what exactly is a container orchestrator? A container orchestrator is just responsible for managing the lifecycle of a container. So it's going to handle the deploying of a container. It's going to handle scaling it up during, peak traffic. It's going to be responsible for restarting and destroying containers, as well as handling the networking and the load balancing of traffic between containers. So really, it's just the brains behind your containerized deployment. So it's going to be responsible for monitoring all the resources, figuring out where should containers get deployed, and it's also going to monitor them in case they crash so that it could tell the container runtime to restart the crashed container. And there's a couple of different orchestrators that are available. The one that I think most people are familiar with is Kubernetes. That's the big one. That's the most popular one. But there's several other orchestrators as well. You also have Docker Swarm. You have HashiCorp Nomad. And you have AWS ECS. So if you aren't familiar with AWS ECS, this is a AWS-specific container orchestrator. So it's a little bit different than Kubernetes. It's not open source. It's specific to just AWS, and it's meant to be a little bit more of a simpler alternative to something like Kubernetes. So that's going to be one of the orchestrators we take a look at, and then we're also going to take a look at EKS, which we'll go over in a bit, but that's just a managed Kubernetes service provided by AWS. So let's start off by taking a look at AWS's Elastic Container Service, or ECS for short. So what is ECS? This is AWS's specific container orchestrator. So this is the one that's proprietary to AWS. And the way that AWS ECS works is that when you actually go to work with the service, you're going to have to create a cluster. So a cluster is basically going to contain all of the resources and everything specific to your ECS-based application. So everything's going to be encompassed within this cluster. And ECS is going to act as the control plane. So this is the brains behind everything. It's going to be the one that's managing the containers and the lifecycle of the containers, just like what a orchestrator is supposed to do. Now, one thing that's important is that ECS is just the brains. It only has all of the logic for managing and automating all of the container-related activities. However, ECS is not responsible for physically running the containers. Remember, it's just the brain. So you have to actually manage the underlying infrastructure for running the containers. And how do you do that? You're going to need some servers someplace. So you're going to have to use, EC2, and you're going to have to create servers on EC2, and then you can then deploy your containers. And the containers are going to be physically running on the servers, and then ECS is going to communicate with those servers to give it instructions. So things like, hey, we need to deploy a few more instances of this specific container. Please go ahead and run those new instances, or maybe it's going to tell them to delete a few or restart a failed container. So remember, ECS is just the brains, but you have to manage the underlying infrastructure, which is just going to be EC2 VMs. So we're going to have to configure EC2 instances to work with ECS. Remember, ECS only manages the control plane. It's our responsibility to provision EC2 instances and then register them with the cluster. Now, when you are configuring EC2 instances, you're going to have to manage the instance all by yourself. ECS is not going to help you there. So you're going to have to apply updates. You're going to have to apply security patches. You're going to have to install a firewall. And basically anything that you would do with a regular server, you're going to have to do here as well. And there's going to be two services or processes that you have to install on your EC2 instance. The first one is going to be a container runtime. Because this EC2 instance is running your containers, you're going to need some sort of container runtime. You can use Docker or one of the other runtimes. And the other thing is going to be an ECS agent. So the ECS agent allows the ECS control plane to communicate with the EC2 instances. So this is how ECS is able to talk to your EC2 instances and give it instructions. And this type of configuration, when it comes to you managing the servers by yourself, this is called an EC2 launch type. I'm telling you guys this because there's actually another launch type, which we'll go over in a second. But anytime you are handling the EC2 instance yourself, this is called an EC2 launch type. And the most important thing to understand with this launch type is you manage the underlying infrastructure all by yourself. ECS does not help with this. AWS does not help with this. You have to provision, you have to maintain, manage, update, patch all of the EC2 instances by yourself. Now let's take a look at the other launch type. The other launch type is called Fargate. So this is going to be a little bit different. And with Fargate, this is another kind of service that comes with AWS. And the whole idea with AWS Fargate is that Fargate follows a serverless architecture. So there are no EC2 servers. There's no EC2 instances. You do not have to create an EC2 instance. You do not have to provision anything. You do not have to manage anything. What actually happens is when you go to deploy an application on ECS, Fargate will actually create the servers on demand. And so what Fargate was actually doing is taking a look at the requirements of your application. It's going to figure out, what is the memory, what's the CPU requirements for your different containers, and it's going to figure out the perfect EC2 instance size to deploy these containers on, and then it's going to dynamically create all of the EC2 instances to be able to handle your specific load. And so you as the user don't have to provision or maintain any of the EC2 servers. You are now offloading this responsibility onto AWS, and AWS is going to manage it for you. And so the great part about this is that you only pay for what you use. And so if you scale back your application or remove some of the containers that you no longer need, what's going to happen is Fargate's going to be intelligent enough to see that, hey, maybe you don't need all of these EC2 instances, and it's going to scale it back down. So you're only running the number of instances that you absolutely need, and you're not paying for extra resources that are just going to be sitting there idly. And so, just to kind of hit home the main differences between the EC2 launch type and the Fargate launch type EC2 launch type, you have to manage all of the underlying EC2 instances. With Fargate, AWS does it. So if you want a more hands-off approach, you're going to use Fargate so that AWS does all the work for you. You don't have to think about it. But if you want full control of the underlying infrastructure, so if you want to make any kind of specific modifications to the EC2 instances, then you're going to want to use an EC2 launch type. So let's now talk about AWS's Elastic Kubernetes service. So what happens if we want to deploy Kubernetes onto AWS? How do we do that? So when it comes to deploying Kubernetes onto AWS, there's actually a couple of different ways to do it. I think the most obvious way of doing it is you would go under EC2 and you'd provision a bunch of servers. And you'd provision a bunch of servers to act as your control plane and your master. And so you'll deploy those EC2 instances, and then you'll use some sort of deployment tool like kubeadmin to configure the control plane and master nodes. And that would involve installing all of the control plane processes on these instances. So that means you're going to install the API server, the scheduler, the controller manager, and etcd. And then you're going to deploy all of the worker nodes. So you're going to create a bunch of EC2 instances to represent your worker nodes. And then on there, you're going to use kubeadmin to install all of the necessary worker processes like kubelet, kubeproxy, and container runtime. Keep in mind, you could use any of the other deployment tools as well. I'm just using this as an example. So this is kind of the most straightforward and standard way. You just create a bunch of VMs on AWS. Some of them will represent your control plane, and some of them will represent your workers, and then you kind of manage everything on your own. All of the individual instances, the control planes and the masters, and the worker nodes, they're all going to be managed by you, and you have to do all of the work of managing your entire Kubernetes cluster on your own. Now, the alternative of managing everything yourself is to use a managed service like Elastic Kubernetes Service. And so with EKS, AWS actually manages the control plane. And so what that really means is that AWS is going to be responsible for provisioning and maintaining all of the master nodes for you. So all of this work is now being offloaded onto AWS. And so AWS is going to handle installing all the control plane processes. And in addition to that, it's going to be responsible for scaling and all of the necessary backups for your control plane. And so by doing this, some of the complexity, especially, really just in the control plane, is now being offloaded to AWS so that you don't have to do this on your own. Now, you will still have to manage the worker nodes yourself, but the entire control plane, everything in yellow, is handled by AWS. So why exactly would you want to use EKS, a managed service, over just deploying everything yourself and managing all of the control nodes and the worker nodes yourself? Well, for one thing, managing and scaling Kubernetes is difficult. It requires a lot of work to get right, and being able to offload this onto AWS is a massive benefit. In addition, if you deploy a Kubernetes cluster, one of the things that you're going to have to spend a lot of time focusing on is security, a very important topic, especially nowadays. And it's hard to get security right, and being able to let a very big and established company like Amazon handle that, who's got a lot of experience with security, a large staff, and a large team that works on this technology on a daily basis, is a massive gain, and it'll give you the confidence of making sure that you don't have to worry about the security, and that your cluster is actually secured and following best practices. And finally, it has tight integrations with AWS services. So when you use EKS, it's very easy to integrate with some of the other services provided by AWS. Things like IAM, S3, Secrets Manager, Load Balancer, they all work together very nicely with managed services like EKS. So we've established that EKS is responsible for managing the control plane. But what about the worker nodes? Who's responsible for that? So when it comes to the worker nodes of a Kubernetes cluster, EKS does not do anything for you. It only manages the control plane, which means that you are responsible for managing the worker nodes. And that means you're responsible for creating the necessary EC2 instances, provisioning them, configuring them, patching them, upgrading them, and installing all of the necessary processes to get them working as worker nodes. Now, AWS does provide several different options for managing worker nodes. In case that you don't want to completely manage them yourselves, there are a couple of options that kind of offload some of the responsibility onto AWS. So the first option is self-managed nodes. So this is exactly what it sounds like. In this case, you manage all the nodes yourself. You do everything by yourself. AWS does not provide any help or assistance in any way, shape, or form. You're doing all of the work of managing the underlying infrastructure for the worker nodes. The other option is managed node groups, and you'll see that this is going to give you, this is going to offload some of the responsibility onto AWS, and it's going to make it a little bit easier to manage some of the nodes. And then finally, you got Fargate, and so this is going to be very similar to Fargate within ECS, where now Fargate and AWS is going to be responsible for managing the nodes, and it's going to follow that serverless architecture. And so really, you're going to see that there's a varying degree of who's responsible for the worker nodes. At the top, self-managed nodes, you're going to be managing it all itself. And as you move down the list, you're going to offload some of the or more of the responsibility onto AWS. So it's really just a matter of how hands-on or how hands-off you want to be as an engineer. So let's take a look at the first method for handling worker nodes, which is the self-managed nodes. Now, with self-managed nodes, all of the EC2 instances must be provisioned and managed by you, the user. And that's going to involve several things. So all of the Kubernetes worker processes must be installed. So that includes kubelet, kubeproxy, and container runtime. So it doesn't matter what container runtime you use, but you're going to have to install all of these different processes yourself after you create your EC2 instances. You're going to have to manage all of the updates and the security patches moving forward. And you're then going to have to register your node with the EKS control plane. And the important thing to understand is that you are doing all of the work in this case. So in this diagram, you can see that AWS does not touch anything. You create the instances, you manage, and you register it with the control plane. Now, the other method for deploying worker nodes is by using a node group. And so you're going to see with node groups, you're going to get a little bit more help from AWS. So a node group is going to automate the provisioning and the lifecycle management of EC2 nodes. So you're not doing everything from scratch. You don't have to do all of the individual things that we kind of covered when it comes to the self-managed nodes. And what's going to happen is all of the nodes, when you deploy, they're going to be running an EKS optimized image so that it makes it a little bit easier to work with. And what it really does is that it's going to give you an easy way to manage the lifecycle of nodes using a single AWS or EKS API call. So instead of you manually connecting and doing all of the individual tasks, you'll just have a couple of API calls for creating new worker nodes, updating them, and terminating them as well. And the great part about using a node group is that EKS is going to manage all the nodes, and it will automatically join them into an auto-scaling group on your behalf. Now, the final way of handling worker nodes is by using Fargate. And so just like with ECS, Fargate allows us to make use of a serverless architecture. So there's no worker nodes provisioned by default. So when you create your cluster and you're using Fargate, there's no worker nodes until you actually deploy your application. So you don't have to create any worker nodes. You don't have to create any EC2 instances. But once you deploy your application onto EKS, Fargate will take a look at the requirements of your application and will actually create the worker nodes on demand. So it will provision all of the underlying infrastructure responsible for running your containerized application or your Kubernetes-based application. You don't need to provision any EC2 servers, and more importantly, you don't need to maintain anything. AWS and Fargate handle everything on their own. And the great part is, based on the container requirements, Fargate is intelligent enough to select the optimal EC2 sizing for your application so that you only have to pay for what you use. And you're not unnecessarily using a EC2 instance that's too large for your application. Fargate will pick the perfect size, and you don't have to worry about it being underpowered for all of the requirements of your application as well. So really with Fargate, AWS is going to handle managing all of the worker nodes. You don't have to touch them. You don't have to look at them. You don't have to update, upgrade, or do anything with the Fargate or any of the underlying infrastructure created by Fargate. It's all being offloaded onto AWS. So if you want the most hands-off approach, Fargate is going to be your best option. So let's take a look at the differences between ECS and EKS. With ECS, it is AWS specific, so there is a certain amount of vendor lock-in. That is something to keep in mind. There's no ECS that's on Azure. Azure may have its own rendition of similar functionality, but the entire API configuration are going to be completely different. So that is something to keep in mind. Whereas EKS is just running a Kubernetes, which is open source, and you're going to have the same API across across the board, across all the cloud providers. So if you want to move to GCP or Azure, it's going to be the same API. So theoretically, it should be a little bit easier to migrate an application running on EKS onto other cloud providers. However, that is purely theoretical. Keep in mind, Kubernetes is fairly complex, and you'll see that there are a lot of Kubernetes specific configuration that works and integrates with AWS's other services. So the more services that you use in AWS, the harder it is going to be to migrate to another cloud provider, even though you are using Kubernetes, which is open source. The other thing is ECS follows a much simpler architecture that leads to faster onboarding. It makes it easy for other engineers to ramp up and understand how to deploy, how to manage, and how to update their containerized applications. ECS just has a much simpler API compared to Kubernetes. And on top of that, pricing for ECS, this is one of the great parts about ECS, is that there's no cost for running the control plane. So even though AWS, they don't charge you for it, you only have to pay for the underlying infrastructure. So all of the EC2 instances and any of the storage associated with those EC2 instances. Now with Kubernetes, it's going to have a much steeper learning curve. We all know Kubernetes is an absolute beast. And on top of that, when it comes to some of the EKS specific functionality and the integrations with it, it's just an extra layer that you're going to have to learn. So when it comes to complexity, you're going to see that EKS and Kubernetes is far, far more complex than ECS. However, with that complexity also comes a larger community. So since Kubernetes is open source and it can be run, you're going to have a much larger community with a lot more support online. Any questions you have, any issues you run into, you're going to be able to get help online. And I promise you, other people have probably run into the same issue. And on top of that, you get access to the entire Kubernetes ecosystem. So you get access to all of the different toolings like Helm, Customize, Argo CD, all of these, and all future things that are kind of associated with the Kubernetes world. You'll get access to it, and you'll be able to make use of it because you are using Kubernetes. And then finally with EKS, it's going to be a little bit more expensive than ECS because you have to now pay for the control plane, as well as the worker nodes that are running your actual containers. So when would we want to use ECS? Well, if your app isn't too complex or is fairly simple and doesn't need to run on Kubernetes, then ECS is the more ideal solution. So ECS is significantly simpler, has a much simpler API, and you don't have to learn everything you need to know about Kubernetes to work with ECS. You'll see that the ECS API is very simple, and configuring it and getting a cluster up and running in ECS is actually very simple, and you don't need to spend a lot of time learning about the overall architecture of ECS. In fact, if you take a look at configuring ECS within the AWS console, you'll see that it's almost like configuring a Docker Compose file. You just provided a list of all of your containers, the configurations for those containers, and then the number of instances of each container. ECS will then take that configuration and then just make sure that whatever requirements you have and the number of instances you want get deployed, and it will make sure that you always have those number of instances of each specific container. In addition, if cost is a factor, then you're probably going to want to prioritize something like ECS because you only have to pay for your actual underlying resources. So even though AWS is providing the control plane, they're not charging you for it, which is great. It's going to lead to cheaper infrastructure costs. You only have to pay for your EC2 instances and EBS as well. So when would you want to use EKS? Well, if you're already using Kubernetes or you need access to Kubernetes specific features or something in the ecosystem, then you're going to have to use EKS in this case because ECS is not compatible with Kubernetes. It's completely a separate software that has nothing to do with Kubernetes. They both are container orchestrators, but outside of that, they don't really have anything in common. So if you're already using Kubernetes, then you're going to have to use EKS. In addition, if you want to prioritize open source technologies and you want to avoid any kind of vendor lock-in, obviously Kubernetes is open source, and it should theoretically, once again, allow you to move between cloud providers a little bit easier, so you don't have as much a vendor lock-in as you would with ECS. And then finally, if you want to leverage some kind of multi-cloud or hybrid cloud solution where you're using Kubernetes as the underlying functionality or feature for managing your containers, you're going to have to use EKS on the AWS side of things so that you can keep using Kubernetes across the other cloud providers. It would be a little bit more difficult where if you were using some sort of Kubernetes solution in Azure, and then in your multi-cloud solution you would start using ECS on the AWS side of things. That would bring a lot more complexity because they're both different technologies, whereas if you're using Kubernetes throughout all of your clouds, then it's going to be a little bit more streamlined. So in that case, you want to stick with EKS because it's using Kubernetes. So both ECS and EKS have their pros and their cons, and there's going to be certain scenarios where you might prefer ECS over EKS, and there might be certain scenarios where you might prefer EKS over ECS. Definitely let me know in the comments which solution or which container orchestrator you guys prefer yourselves for your organization. And I think that's going to pretty much wrap up this video. We've gotten a chance to learn a lot. We've covered the main features and functionalities of ECS and EKS and how both of those container orchestrators and services work. And we've also gotten a chance to analyze the differences between the two and when you would want to prioritize one solution over another. So to quickly recap what we've covered in this video, both ECS and EKS have their pros and cons. There's going to be certain scenarios where you prefer one over the other. There's going to be times where you may prefer ECS over EKS, and there's going to be times where you may prefer EKS over ECS. Definitely let me know in the comments which container orchestrator you prefer, which one you prefer to use in personal projects, which ones you prefer to use in professional environments. And I think that's going to wrap up this video. We've gotten a chance to cover a lot of different things. We've covered all of the different main features and functionalities of both ECS and EKS, and we were able to analyze the differences between the two and when we would want to prioritize one over the other. And so I think that's going to wrap up this video, and I will see you guys in the next one.